Hello Year 12. Second, research methods, PowerPoint, so getting back into the routine, PowerPoint, video accompanying it, and then having a go at some questions from the research methods guide that I sent out last time. Okay, so I know it's quite a lengthy title here, lots of things, but actually there's not that much you can say about them, and as before, a lot of this shouldn't be new. You should have heard of this frequently during the course so far. Okay, so the first thing, aims. Always surprised when students can't give me the aim of a study. Why are they doing this? Sometimes you could be looking there with all the procedures, in the findings sometimes, well, what was the aim of the study? What were they trying to investigate here? So it should be fairly obvious. It's just a concise statement of what was being investigated. So with experiments, it'd be to examine the effect of something on something. We will get almost templates in your heads to use for aims, writing a hypothesis, to make sure they're the right kind of format. So as I've said here, maybe pause me for a moment and think, okay, what have we studied so far? What experiments from the social topic or from the memory topic? You've got those ones on interference perhaps. What would be the aim of those studies? Okay, but those are aims. There's not too much more to say about it. Obviously the page numbers are there for you to refer to either as you go, or you might want to listen to me and read this and then have a look at the booklet. IB and DB, independent variable, dependent variable, they've got to be there. If it's not there, if you can't identify conditions, the IB, then it's not an experiment, it's something else. So independent variable is what you're directly manipulating. It's what you're changing between the conditions, and in an experiment you're assuming that your changes in the IB will affect the DB, the dependent variable that you're measuring. So IB is what you manipulate, what you change between the conditions. DB is what you're measuring, and in an experiment you're assuming that any changes in the dependent variable were due to your manipulation of the independent variable. Okay, and again, if you pause me, there is an example on page 25. Yes, it's all there anyway, but try and think for yourself before you read it. What would you say? Now, something that students tend to be surprisingly weak at, writing a hypothesis. Not just us, but a lot of examiners' reports will talk about hypothesis writing. It's another one a bit like aims. I don't quite know why. But yeah, I get all sorts of weird, wonderful things, mini essays on it. A hypothesis is just a concise statement, a concise prediction of the difference, or if it's a correlation, the relationship that you're going to see in a study. Now, operationalizing things just means it needs to be clearly defined. It's got to be precise. So you can't just say time or something like that. You've got to say how exactly, number of things done in 30 seconds. So yeah. Hypothesis, we will look at, there's examples in the booklet, we will look at templates next year, when hopefully we're back together, just to make sure that you're almost filling in the gaps when you're writing a hypothesis. Now, something you do need to watch out for, you might be asked for a directional or non-directional hypothesis, or you might be asked to suggest an appropriate hypothesis. So directional predicts the specific nature of the difference. So this group will do more, less, faster, slower than that group. And that would be a directional because it gives you the direction. Non-directional, there will be a difference between the conditions, but that's where you stop. You don't say which way it will be. If you were looking at a correlational study, you would say there will be a positive correlation. No, sorry, you wouldn't. You'd say there'd be a correlation, but you wouldn't say that'd be positive. Okay, I really stuffed that one up. Right, not supposed to be talking about correlations anyway. So experiments, directional or non-directional, it is actually really important that you know those. Yes, because you could be asked for them, but it also has implications for lovely inferential statistical tests that we do next year. Okay, so you do need to get this clear. Why would you use directional? Why would you use non-directional? That's a question you might get asked. Directional tends to be because previous research suggests that this will be the case. Non-directional, if there isn't previous research, or potentially if there's mixed findings, tends to be almost the first sentence of what you read on an exam paper A researcher couldn't find non-directional. Previous research has suggested directional, so it shouldn't be too tricky to know which one you would use. Now, I'm throwing this in here because it's in there in the book. We have to mention it at some point. Maybe it doesn't fit in completely with experiments. This applies to whatever study you're doing. What is a pilot study? Why do we do them? So a pilot study, a small-scale trial version of the proposed study to check it's effective, to check it works, basically, and to then subsequently make any improvements. In other disciplines, you might call it a prototype, where you make a small version of it and then you see how it works and you think, oh, actually, that doesn't work so well, we need to change that. That's what we're dealing with here. So experiments, whenever you're asked about a pilot study, why would they do one? You just got to think about, well, what needs to be checked here, or what could go wrong? What do we need to check? So the design of the study, is it appropriate? Does it work? Are the instructions for participants clear enough? Are the materials clear enough? If you're doing some sort of identification task on photos, is it clear enough? If they're watching a video, is it clear enough? The measures that you're using, are they clearly defined and suitable? If they're doing some sort of task, is it too easy? You can get it, but it's so easy. People do it regardless of the conditions, or it might be too hard. And whether they're sitting in a hot room or a cold room or whatever, nobody could do it at all because it's too hard. All of these things you need to know before you do your full-scale study, the final study. You might be inviting 100 people along lined up to do this. You need to know if it's not going to work. You need to know that in advance to get it fixed. But it's not just experiments. Observations. You don't want to be rocking up somewhere ready to do this and then suddenly find, hold on, our categories don't work. Questionnaire. Oh, the number of questionnaires we get in registers at school. We think that doesn't work. It doesn't make sense. You just asked me 2 questions within one thing. How do I answer that? So no matter what you're doing, it needs to be checked. You could be duplicating, paying postage for loads of my degree. I posted out questionnaires to loads of people. If I'd have made a mistake on there, that'd be a big problem. I need to know that it's okay before you do it. So that's what a pilot study is all about. And just a point to bear in mind, your sample that you use for the pilot study does need to be representative of the sample that you use for the real thing. If I'm doing my main study is going to be on the elderly, I can't sort of say, oh, actually, year 12, you're here. Let's have a quick go at this. Yeah, it's fine. Yeah, it might be fine, but it might not work for that group. So you do need to still find a small but representative sample for your pilot study. Experimental design. Yeah, please be careful. Last time we did type of experiment, lab, field, natural, quasi. Then you've got what experimental design you're going to use. So please be careful. Sometimes people rush and get them mixed up. Very frustrating. So there's 3 that you need to know. You need to be able to describe what they mean. You need to be able to identify them from a scenario and say, oh yeah, that's what they've used here. You need to be able to apply it. You could potentially have to create a study yourself or proposal, and they might tell you which design to use, or you might have to justify it. And again, you need to know your pros and cons of each one as well. So repeated measures, independent measures, matched pairs. So repeated measures, the same participants take part in each condition. So you've got 2 conditions in your study. They do condition A and then they do condition B. That's repeated measures. All participants do both conditions. Just get that in your heads. Now, advantages, disadvantages. Quite a practical thing, but yes, it does require fewer participants than what's coming next, independent measures. Let's say you want 50 people to complete each condition. Repeated measures, you need 50 people, 50 participants, because they're going to do both condition. Next one, that wouldn't be the case. You'd need 100. So we'll come to that in a bit. So that's a practical benefit of repeated measures. We will talk about most of these on the next slide as well. What's the strength of one is a weakness of the other and vice versa. So this reduces the risk of individual difference, participant variables affecting the outcome of the study. So if you've got different people doing your 2 conditions, there's a risk that there might be something about those people in one group that's different to the others. Repeated measures, you've got the same people in each one, so that reduces or takes away that risk. However, while that's hugely beneficial, there are significant issues as well. First of all, if participants see both conditions, then there's a risk of demand characteristics. There's a risk they might guess the aim of the study. If they do that, then you're on dodgy ground. You can get people doing what they feel they should be doing rather than acting naturally. If people guess the aim of a study, and I've certainly been in this position as the guinea pig at uni for the year 3s doing their final studies, where you're sitting there thinking, I know exactly what you're doing. And you've got the angel on one shoulder saying, oh, don't mess it up for them, do what they want it to do. You've got the devil on the other shoulder saying, stuff it up. Whatever. If you're not acting naturally, then that's a problem. If you see both conditions, then there's an increased risk of you guessing the aim and showing these demand characteristics. And then probably the most important one, and I guarantee if you see anything on repeated measures, you'll get a question that's looking for you to talk about order effects. So if you're going to do condition A and then you do condition B, regardless of whether the independent variable is hot room, cold room, it could be that people do better in condition B because they got better at the task that you're asking them to do. So if you had them do some sort of puzzle, word search, in condition A, might not have done a word search for quite a while, it might take them a while to get going. It might be that then when they come to do word searches in condition B, they're in the word search zone, and suddenly they've got their technique going and they do better. You think it's down to them doing it in a hot room, when actually it's got nothing to do with it. It's practice effects. However, you can also get the opposite, and they could do worse through fatigue, boredom, if they're repeating a task as well. Okay, so if you see repeated measures, at some point there's bound to be a question that's asking you about order effects, and there's a good chance you're going to be asked about how you could overcome these order effects. And well, one option is to scrap it and do a different design, or more likely, you would use ABBA. Okay, so why is ABBA useful when we're talking about repeated measures and the risk of order effects and how to overcome them? Well, basically, it's called counterbalancing. So get this sequence in your head. Repeated measures, problem of order effects, overcome with counterbalancing. And what this means, this is where the ABBA comes into it. You split your participants in half, not literally, but two groups. You've then got half of them do condition A followed by condition B. The other half do condition B followed by condition A. It's still repeated measures. You've still got your 50 participants who have done both conditions, but they've done them in different orders. Half have done one A followed by B, the other B followed by A. Now this is important. It sounds really picky. We had quite a debate on it at a psychology head meeting. It doesn't remove order effects. There are still 50 orders in which things have been done. But rather than one condition getting all the benefit or the detrimental effect of going second, it's split evenly between the two. So don't say removes order effects, but it offsets any advantage or disadvantage, counteracts any order effects, that sort of language. Don't say gets rid of or removes order effects. So that's repeated measures, or the other main one you see is independent groups. Elsewhere you might see independent measures, same thing, but this is the specification wording, so that's how it should be worded in an exam. Now this is basically where you use different participants for each condition. You've got your participants, they'll either do condition A or they'll do condition B, unlike repeated measures where they all do A and all do B. They should be randomly assigned to those conditions. So what's the good thing about doing this compared to the last one? As I said, these points will seem familiar. It's just the reverse. So if you've got the problem of order effects with repeated measures, then you avoid order effects with independent groups. They only do one condition. Likewise, the demand characteristics, guessing the aim. If you only do one condition, you're much less likely to guess the aim of the study. However, as I said earlier, you do need more participants, double the number of participants than you need for repeated measures. It's easier said than done, rounding up the participants, particularly if you want a decent size sample. And crucially, participant variables might affect the results. It could be that the nature of the people in condition A leads to that group being different to the other one, which could affect the outcome in ways other than your independent variable. If we go with the hot room, cold room condition, if they're doing some sort of task and you've got a couple of, I don't know, whizzes in there who are really good at these kind of things, that could distort it, and you think, oh, actually, yeah, cold rooms really improve cognitive functioning. Actually, no, by chance you ended up with more able people in that group. So repeated measures, that wouldn't be a problem because you've got the same people doing both conditions. Okay, so the evaluation for this is quite easy to remember. What's the strength of one is a weakness for the other, and you can always play them off. Even if you're asked to talk about one, you might make reference in your evaluation to the alternative. And then last one you need to know is matched pairs. Structurally, it's still independent groups. You've still got participants will do just the one condition. But rather than just this random allocation, you've got this matching going on. And the clues in the title, matched pairs, you match them in pairs on whatever trait is significant to your study. Please think about the nature of the study and what's significant. I have seen eye colour, hair colour, shoe size, all sorts of stuff before. Key ones are IQ and things like that to be measured on. You pair them in matched pairs, so those two with the highest IQs on your measure, they would be your first pair. The first person from that pair would do condition A, the other would go into condition B, and so on. I'll probably use the example in class if I was doing different revision techniques for psychology students ahead of a test. It would make sense for me to do some sort of matching just in case by chance I end up with the most able students in one of the conditions. So I could look at your most recent test score, average test scores, top two averages, first student would go in condition A, the other would go in condition B, and so on. Okay, so that's matched pairs. So why might we think about matched pairs? Well, this issue of if we still want independent measures, because it gets rid of the order effect still, but we're worried about these participant variables, then this helps to overcome that. So that's the main reason why you do it. You don't want to do repeated measures, but you also want to reduce the risk of independent individual characteristics affecting the outcome. So this helps with that. But you've still got the standard issue that you will need more participants than repeated measures. And yeah, you're matching them, but they're not clones. There's still going to be an element of participant variables there. Go to the psychology example. Not that it is the case, of course, but there could be a student who's head and shoulders above everybody else, and they're number one on the list, and then comes number two. That's my pair that have been matched, and the most able student by far is still going to go into one condition. So that's a slightly extreme example, but still you get the idea. It's not an exact match, so there still is some risk. It doesn't get rid of any risk of these participant variables creeping in. Okay, so that's what I want to cover this time. So I'm going with I'm not going with the order that the book is in, the specs in that order as well. I'm sort of grouping things together. So we're starting off broadly speaking about experiments, and then we'll move on next time. So read the full spreads in the topic companion. Don't skim it. I don't want students doing the sort of bare minimum reading to get the questions done. Oh, there you go. He'll be happy. He's got his answers now. You need to get this. This is crucial. So take your time. Think, do I get this? Read the topic companion. Read the relevant spreads in the textbook. Obviously, gives you a lot more depth there, the bigger picture. I've tried to pick out the key ones for today. But then, as with last time, you need to have reference to the topic companion. That's where the questions are with the prompts. And as you will have seen, some of them are very helpful and give you a lot of direction. And then you need the Word document to complete your answers on. Okay, so that's what I need you to do this time. Deadline is next Friday. Now, I managed to do all of this yesterday and then delete the whole thing. We'll learn about the frustration regression hypothesis next year. Let's try and get it right this time. So fingers crossed you'll have this video tomorrow ready to help you with this task. Okay, thank you.